Next definition, sinusoidal. Sinusoidal waveforms are periodic waveforms whose shape can be plotted using the sine or cosine function from trigonometry. We know sine function is about x-axis will go up and down, right? Like a wave. Similarly, cos also, right? So sinusoidal is the waveform indicating that wave is in the form of sine or cosine, right? So that is what it is called sinusoidal. Sine wave with white noise. Sine wave with white noise means a equally distributed white noise as added on top of the random pure sine wave signal will create a waveform that appears as a slightly irregular oscillation around the original sine wave path. We are adding up two waves, right? One is sine, one is white noise. So you will get the result that the another wave, it is an irregular oscillation around the original sine wave path, right? That is what mixing two sounds, you will get another sound, right? Same thing, right? So consider a random process x of t consisting of a sinusoidal wave component a cos 2 pi fct plus theta and a white noise process wt of 0 mean and psd power spectral density is equal to n0 by 2 defined by x of t, which is equal to a cos 2 pi fct plus theta plus wt, where a and fc are constant. Theta is uniformly distributed random variable over 0 to 2 pi. So Gaussian white noise. This Gaussian white noise is indicated by GWN, is a random process that is stationary, ergodic, and has a zero mean, right? See, this is the example of sine wave with white noise. First sine wave, then white noise, right? Then you will get sine plus white noise, right? Next problem, y of t is equal to a cos w naught t plus theta plus n of t, where a is a constant, theta is a random variable with a uniform distribution in minus pi to plus pi, and n of t is a band limited Gaussian white noise with power spectral density Snn of w, which is equal to n0 by 2, modulus w minus w naught less than wb, 0 elsewhere. Find the autocorrelation of n of t and power spectral density of y of t. Assume that n of t and theta are independent. Given Snn of w, which is equal to n0 by 2, modulus w minus w naught less than wb equal to 0 elsewhere. Theta is a random variable with uniformly distributed in minus pi to plus pi. We know uniform distribution PDF is given by f of theta, which is equal to minus pi minus minus pi. My theta lies between minus pi and plus pi, 0 otherwise. We know for a uniform distribution, if x lies between a and b, so its PDF f of x is given by 1 by b minus a, upper limit minus lower limit, right? Here upper limit is pi, lower limit is minus pi, so pi minus minus pi, right? That is equation number 2. Given n of t is a Gaussian white noise, so mean is nothing but 0, right? That is equation number 3. Now r y of t1 comma t2, which is equal to expected value of y of t1 y into y of t2. Substituting y values from equation number 1, expected value of a into cos w naught t1 plus theta plus nt1 into a cos w naught t2 plus theta plus nt2, multiplying each and every terms. So first bracket first term, a, second bracket second term. So a into a square cos w naught t1 plus theta into cos w naught t2 plus theta. So first bracket first one, second bracket second term. So a cos w naught t2 plus theta into n t1. This then a cos w naught t1 and theta into n t2. So first bracket second term, second bracket first term, right? And then first bracket second term, second bracket second term, nt1 into nt2. So a square is a constant, right? I have given a is a constant. So taking outside from the expectation, a square e cos w naught t1 plus theta e cos w naught t2 plus theta plus a into e cos w naught t2 plus theta into e n of t1 plus a e cos w naught t1 plus theta into e n of t2, then expected value of n of t1, n of t2. A square e expected value of cos w naught t1 plus theta cos w naught t2 plus theta, and that is a into e cos, because e of n of t equal to 0, right? We know. So whatever whatever the t values, expected value of n of t equal to 0. Therefore, in the first second bracket, expected value of something into expected value of n of t1. Instead of t, you are having t1, so that is 0. In the third bracket, you are having n of t2. Instead of t, you are having t2, that is also 0. Last term, n of t1, n of t2, both are 0. So sorry, n of t1 into n of t2, expected value of n of t1 into n of t2 is nothing but autocorrelation, n or n of t1 t2, right? Therefore, a square by 2 expected value of cos w naught t1 plus w naught t2 plus 2 theta plus cos w naught t1 minus w naught t2. We are using here cos a cos b formula, which is equal to half of cos a plus b into cos a plus b plus cos a minus b. Here a is nothing but w naught t1 plus theta, and b is nothing but w naught t2 plus theta, right? Plus rn of t1 t2. Then that is equal to a square by 2 expected value of cos w naught t1 minus t2, right? Plus a square by 2 expected value of cos w naught t1 plus w naught t2 plus 2 theta plus r nn of tau, which is equal to a square by 2 cos minus, so we are taking minus outside, minus w naught t2 minus t1 plus a square by 2, applying expected value definition, minus pi to plus pi cos w naught t1 plus w naught t2 plus 2 theta into f of theta d theta plus r nn of tau. We know expected value of x is equal to, if in the case of continuous function, integral minus infinite to plus infinite x into f of x dx. F of x is the PDF of that uniform distribution. Here f of theta, right? We are using that formula. A square by 2 expected value of cos minus w naught t2 minus t1 plus a square by 2 integral minus pi to plus pi cos w naught t1 plus w naught t2 plus 2 theta into f of theta d theta plus r nn of tau. We know f of theta, which is equal to 1 by 2 pi. Therefore, r yy of t1 t2, which is equal to a square by 2. So here cos of t2 minus t1, the t2 minus t1 is tau, right? We know, right? Difference of the difference between the time, right? We know t plus tau, like that. T2 minus t1 is equal to tau. So replacing that one, t2 minus t1 equal to tau. So you are having cos minus w naught tau plus a square by 2 integral minus pi to plus pi cos w naught t1 plus w naught t2 plus 2 theta into f, instead of f of theta you replaced 1 by 2 pi d theta plus r nn of tau is equal to, so cos of minus theta cos theta a square by 2 cos w naught tau plus a square by 2. So integrating cos of a plus b plus cx which is equal to sin a plus b plus cx by c. So same thing. So a square by 2 1 by 2 pi sin w naught t1 plus w naught t2 plus 2 theta. Instead of x you are having theta. Instead of c you are having 2. A plus b is nothing but w naught t1 plus w naught t2 plus r nn of tau. So applying upper and lower limit, a square by 2 cos w naught tau plus a square by 2 1 by 2 pi sin w naught t1 plus w naught t2 plus 2 pi minus sin w naught t1 plus w naught t2 minus 2 pi. So upper limit pi, lower limit minus pi plus Rn of tau is equal to a square by 2 cos w naught tau plus a square by 2 1 by 4 pi. So 2 pi into 2, so 4 pi, right? Sin w naught t1 plus w naught t2 minus sin minus 2 pi minus w naught t1 plus w naught t2, taking minus outside, plus Rn of tau. We know sin 2 pi of x is equal to sin x, that is why. So sin minus x becomes sin x, right? We are using that formula, a square by 2 cos w naught tau plus a square by 2 1 by 4 pi sin w naught t1 plus w naught t2 plus sin 2 pi minus w naught t1 plus w naught t2 plus Rn of tau. Sin 2 pi minus theta minus sin theta. So we are using that formula again, a square by 2 cos w naught tau plus a square by 2 1 by 4 pi sin w naught t1 plus w naught t2 minus sin, here you are using that the formula, sin 2 pi minus x is equal to minus sin x minus w naught t1 plus w naught t2. So sin w naught t1 plus w naught t2 minus sin w naught t1 plus w naught t2 get cancelled. So second term will become 0, right? So a square by 2 cos w naught tau plus Rn of tau, that is equation number 3. To find the autocorrelation n of t, that is Rn of tau. So Fourier transform of Rn of tau is equal to Snn of w. So Rn of tau is equal to, so inverse, taking inverse Fourier transformation, f inverse of Snn of w, applying inverse Fourier transformation 1 by 2 pi integral w naught minus wb, w naught plus wb, n naught by 2 e power I w tau d tau. So you will get is equal to n naught e power I w tau by 2 pi w tau. So sin wb tau, that is equation number 4. To find PSD, power spectral density of y of t, syy of w. PSD of y of t is given by syi of w, which is equal to Fourier transform of ryy of tau, which is equal to Fourier transform of replacing ryy. So a square by 2 cos w naught tau plus Rnn tau. So syi of w is equal to a square by 2 for Fourier transform of cos w naught tau plus Fourier transform of Rnn of tau. So a square by 2 Fourier transform of cos w naught tau, Fourier transform of Rnn is nothing but Snn. It is equation number 5. To find f cos w naught tau is equal to minus infinite to plus infinite cos w naught tau e power minus I w naught tau d tau. So we are applying the definition of Fourier transform is equal to minus infinite to plus infinite. Cos can be written as e power w naught I tau plus e power I minus w naught I tau by 2 into e power minus I w tau d tau, which is equal to 1 by 2 integral minus infinite to plus infinite e power w naught I tau into e power minus I w tau d tau, plus we are splitting the integral, plus 1 by 2 integral minus infinite to plus infinite e power minus w naught I tau into e power minus I w tau. So splitting the power also, right? So which is equal to 1 by 2 integral minus infinite to plus infinite, grouping the power e powers. So w naught minus w I tau d tau plus a half minus infinite to plus infinite e power minus w naught plus w I tau d tau, which is equal to 1 by 2. So we know e power w naught minus w I tau is nothing but direct delta function, del of w naught minus w, right? And del t plus or minus w, which is equal to 1 by 2 pi integral minus infinite to plus infinite e power t plus or minus w e tau. Instead of t minus w, you are having w naught minus w. So replacing of 2 pi del w naught minus w. In the second one, 2 pi del w naught plus w. So 2 get cancelled. So you will get pi del w naught minus w plus w naught plus w, equation number 6. So 5 and 6, from 5 and 6, syy of w, which is equal to a square by 2 pi del w naught minus w plus del w naught plus w plus Snn of w, right? Thanks. things. We'll see in the next video.